Boys and girls, we are continuing with trigonometry. We're going to learn cofunctions in a right-angled triangle. Right, in this right-angled triangle, right, we have angle theta, and then we can find that angle in terms of theta by using sum of angles of triangle. That angle is 90 minus theta by sum of angles of a triangle. Now, if we find the ratio of the sine of theta from this triangle, we know the ratio of a sine of an angle is opposite side divided by hypotenuse, which is b divided by c. Now, let's check. Let's find the cos. The cos of that angle, 90 minus theta. Remember, the cos of an angle is adjacent side divided by hypotenuse. So the adjacent side is b divided by hypotenuse is c. Now, these two are equal. Now, we can conclude by saying the cos of 90 minus theta is the same as the sine of theta. So the cofunction of the sine, it is the cos in this case. Right, now if you check, the sum of these angles is equal to 90. Right, this can happen vice versa. Now the sine of 90 minus theta. Right, to the diagram, the sine of an angle is opposite side, which is a, divided by hypotenuse is c. Let's find the cos of theta. The cos of theta of this angle is adjacent side divided by hypotenuse. Adjacent of that angle is a divided by hypotenuse is c. Now we can see that the sine of 90 minus theta is the same as the cos of theta. So this is the cofunction. Sine 90 minus theta is the same as the cos of theta. Right, if the sum of these angles is 90, then the sine of the angle is equal to the cos of the other angle if the sum is 90. Let's do an example again. Right, so when we continue, we can simply say the sine of 90 minus 30 degrees is the same as the cos of 30 degrees. Because when we add these angles, we get 90. If this one is 60, then it's the same as the cos of 30 degrees. Right, the last example, if we have the cos of 90 minus 15 degrees, this is the same as the sine of 15 degrees, because the sum of these angles add up to 90. So in general, we simply say the sine of 90 minus theta is the same as cos of theta, and then the cos of 90 minus theta is the same as the sine of theta. That's all about cofunctions. Now, boys and girls, cofunctions, reduction formula. Remember, reduction formula is about rotation of the arm in the quadrants. Now, in the first quadrant now, let's use the definition 90 minus theta. Now the arm is rotated and then is in line with 90. Then we subtract theta. Where are we going to write that theta? 90 completed the arm. When we draw the arm all around and we put it there, it's 90. Then we subtract theta. When we subtract theta, the arm is going to go back. Then where is that theta? Theta is now here. Now we talk about the definition of 90 minus theta. Now when we refer to theta, that theta that we're going to refer to is now here. It's no longer in connection with the arm and the x-axis. So this is no longer our reference angle. Remember, the reference angle is the angle between the x-axis and the arm. This is the correct reference angle. Right, now we are forced to join the y-axis to form a right-angled triangle, because now theta is here. 90 completed, then we subtracted theta. Now this distance from here to there is represented by x, and then this one is y. You can see it. Now when you find the definition of a function of this angle, for example, the sine of theta is equal to opposite divided by hypotenuse. Hypotenuse is the length of the radius r. Now this is x over r, but under normal circumstances, when we use the correct reference angle, you will never find the sine of theta x over r, but now suddenly it's x over r, which is cos. Can you see? So this is a cofunction, 90 minus theta. So understand that the cos of 90 minus theta is the same as the sine of theta. Right, again in the second quadrant, the very same thing applied. Now, don't be surprised when we find 90 plus. Now the definition of 90 plus theta. Right, if the arm is rotated and we complete theta, now they say add theta, then we're gonna add theta. That theta will be here. Right, this is not a reference angle. Remember, the reference angle is the angle between the x-axis and the arm. Right, that will give us the correct definition, those definitions there. Right, when we join, we are forced to join the y-axis here so that we include that angle mentioned, 90 plus theta. Now, the very same thing that I explained that side is applied. Let's find the sine of theta. In this case, it is opposite divided by hypotenuse, which is x over r. And when we choose 90 minus theta, 90 minus theta, it will be x over r. So then in this case here, be careful in the second quadrant. In this case, let's say we have cos of 90 plus theta. This is now, we're going to look at this function in that quadrant. Is it positive or is it negative? So in this case, the cos of an angle in that quadrant is negative. Then it will be negative the cos of, the sine of theta. We can try this with numbers or angles. You're going to see it. If we have the cos of 90 degrees, let's say plus 30 degrees. Right, in which quadrant is this? Remember, 90 plus theta will lead us to a cofunction. Now, the cofunction of cos is sine. Then, in this quadrant, the cos is negative. Negative. The sine of, don't forget the cofunction, sine of 30 degrees. When you press this on your calculator, you're going to get the same answer as this one. That is the understanding of cofunction. So be careful. The cofunction is about sine and cos. If you are given again the sine of 90 plus theta. Now this is the second quadrant. Then we check this function. Is it positive or negative? It is positive. Then before we change it to its cofunction, positive the cos of theta. Then with angles, we can show that this is true. 90 plus 60 degrees, for example. 90 plus 60. This is the same as positive the cos of 60 degrees. That is all about cofunctions. Please, whenever you see 90 plus theta, it can be changed to cos of theta and vice versa.